This video is about the gray code being used for a starting tray solution. Over here on the right is the gray code search that was for the first 18 bits. But it started with a tray left, a tray income, and down here a tray list for bits. That's because perhaps there was a 19th bit that could be set on. If the 19th bit was to be on, then this tray left wouldn't be all that was on hand, but was what was on hand less what was used for the 19th bit. And down here, the current income would have to start at the income for that 19th bit already being in the solution. So here, gray left was started with tray left, and the current income was started at the tray income, because the 19th bit, for instance, was already in the solution. But there could be others, the 19th, the 20th, the 21st, and so forth. And if they're in or out of the solution, tray left and tray income could be changed. So that means the start of this gray code search already had a partial solution in it. And down below here, when it moves into best list, the test list of the first 18, it also has to move into there at best list plus 18, whether or not the 19th bit is on, the 20th bit is on, and so forth. Now we're going to look at the routine over here, the one that works with what we're going to call the extra bits. The extra bits are all the bits over bit 18, starting then at bit 19. This is executed every time the program restarts. It first says on the screen it's working on the solution. Then it increases the value of y by 40, so it's dropping down on the screen position, and this box N is going to show the loop index on the screen. Then it's going to drop down the y position a little more, and it's going to show the loop count on the screen. When the loop index is greater than the loop count, it's going to be over. The loop index starts at index 1. The next line says if the loop index is greater than the loop count, go to BJ, that's down here, and that is done when it's over. However, if it hasn't done that, it comes down here and it says if the loop index is equal to 1, go to BH. That comes down here and it just calls this routine over here, the search. When it calls it, all the values for tray income, tray left, and tray list are 0. So it first does the search if none of these extra bits are in the solution. If, on the other hand, the loop index is greater than 1, it comes down here and sets NM to 18. This is in the main program, so all control registers end with an M. Notice up here where Y was increased, it was YM for the control register for the main program. Well, this one is NM, the control register for the main program. And down here, these two instructions of add list need to know what that value is because they're going to add two lists together. It needs to know how many numbers are in each of the lists. Next, it sets I to the loop index, subtracts 1 from I. Now that loop index the second time will be 2, so it subtracts 1 from I, so now I is 1. Then it sets J the offsets of I. It's using the gray code offsets again, but now it's using them for these extra bits. It then says add to the tray income what is in gray data at offset 2360 plus J. Well, what that says is 360 has already been added, and remember there's 20 offsets for each bit. 18 have already been used, so this is the 19th one. So we also have to add the fact that we're going past the first 360. That is added to income, so it will add it to income, but because it's using these offsets, there's times when it's going to subtract it from the income because it's taking it out of the solution. Next, we have the add list instructions. We'll take whatever the requirements were for this and subtracts them from what's left if it's adding it to the solution. But with these offsets, it could actually be subtracting it from the solution. So that could go either way. They're either plus or minus. Also, down below that, to the tray list itself. Now here at the tray list, it didn't have to add 360 to it because it's starting this tray list all at the beginning again, just like the first 18 were. This is just a separate list, and it's going to set the bits on in tray list. Remember over here, we got put into the best list though at offset 18, meaning it was for the extra bits. Alright, once it comes through here, then it's going to call 202, which means the second subprogram, tab 2. And that's what this is over here. Here it says tab 2, and this is in the second subprogram. So it calls it, then it adds 1 to the loop index and exits. But the next time it starts, then it's going to come down here, still saying it's working. The loop index will be increased by 1. Loop count it shows will be the same count. And then if it's going around here enough times so that loop index is greater than the loop count, it'll go to BJ. Now one thing to point out, if there are no extra bits, of course it's only going to do this one time, because the loop index will stop it right away. But if there is a bit 19, it'll come around here for when the tray list is not being changed at all, and it'll run this routine. And next time around it'll be 1, and then it's going to run it again for the 19th bit. But what you got to understand is when there's a 19th and a 20th bit, it's going to go through here for neither one being on, for the 19th being on by itself, the 20th being on by itself, or the 19th and the 20th being on. So this loop count gets increased by powers of 2. There's 1, there's 2, there's 4, there's 8, there's 16, there's 32. So it grows exponentially with the number of extra bits that are going to be in this, possibly in the solution. Now, we didn't say here that this BJ, when it finally gets done with all the looping, it goes to BJ. Then it calls subprogram 2, but tab 3, which is used to get the quantities out of using the best list. And we went over that routine. Then it sets the task back to 1, which means it's no longer doing the search. It's never going to come here and say it's working on the solution anymore because it has the solution. Well, this is the end of the video about the gray code being used for the tray solution.